Kia ora, Year 11 and 12. This is a question from Pablo from the November 2014 paper. It's a good example of factor theorem and also of polynomial long division again. Okay, so let's have a look at it. Where are we? Right, here's the question here. So we're given a polynomial and we've got a couple of things that are missing, a couple of coefficients that we have to work out. So here's the polynomial and we're told that x plus 1 and x plus 2 are factors of p of x. So as soon as we see that, we know that this problem's not going to be too bad because we've got two missing bits of information here. We're missing a and we're missing b, but we've got two factors. So by the factor theorem, we know that if x plus 1 is a factor, then when we put x equals -1 into the polynomial, then we have to get 0. And we know that when we put in -2, we also have to get 0, right? Because 0, x plus 2 is a factor and x plus 1 is a factor. So we're going to do that, and that's going to generate a pair of simultaneous equations. And that's all we need because we've got two equations and we've got two unknowns. So that's step one, and then we're going to put those values back in and do some long division. Right, so substituting in, we get p of -1 is equal to -4 plus a minus b minus 2, and that equals 0. That gives me a minus b is equal to 6. We do the same thing for -2, and we get 4 times -8 plus 4a minus 2b minus 2, and we know that that equals 0. So when we clean that up, we get 4a minus 2b is 34, and we can divide that through and get 2a minus b is 17. So I've got this and this. You can do substitution or elimination, but in this case, I'd probably go b is equal to a minus 6 from here, and then sub it into here. So we get 2a minus a minus 6 is equal to 17. A is equal to 11, which gives us b is equal to 11 minus 6, which is 5. So there you go. Now, the next part of the question is a good example of being careful with place value when we do long division. So when a and b have got these values, find the remainder when p of x is divided by x squared plus 1. So as I said in the video that I just made, it is by far the easiest thing to do polynomial long division here. But you can also do the matching up method that I did in the other video. I'm not going to do that here. So let's substitute in the values of a and b and see what that looks like. Okay, so we've got p of x is now equal to 4x cubed plus 11x squared plus 5x minus 2. So my long division is going to go like this. In here, I'm going to have 4x cubed plus 11x squared plus 5x minus 2. And here I'm going to have x squared. Now I want x squared plus 1. But if I try doing that, things are going to go very bad. So we're going to put in the placeholder for the 0x column. Right, now we're going to match up. X squared times what will give me 4x squared? Well, it's going to be 4x. So it's a pretty easy long division problem. 4x cubed plus 0 plus 4x. Subtract all of that and see what's left over. Now I've got 11x squared plus x minus 2. So we're matching on the 11x squared. We're going to have plus 11 up here. Next we get 11x squared plus 0 plus 11, and we subtract all of that. That's going to give me my remainder. What do we have here? So we've got 0, then x minus 0, minus 2 minus 11, x minus 13. What were we asked for? Well, we were asked to find the remainder. So the remainder is what falls out the bottom, and we're just going to write that out. So remainder is x minus 13. Oop, where's it gone? X minus 13. There you go. Now, if you did that and you knew that you were trying to show that something was a factor using long division, you would be obviously getting 0 down here as the remainder. And if you didn't, you'd know you'd mucked something up. Thanks for watching. Great that you're starting to email me in questions. Please keep on doing that, and I'll choose some of my own to do over the next day or two.